Good morning or good afternoon, everyone. By everyone is Akash. Is there? That's good. So can you hear me well? Akash, can you hear me well? Can you see me too? Well, I don't know. So let me start my business. So good afternoon, everyone. This is being taped, and so far I haven't received any email from students. So what I would do, I go over and show if I were a student, what would I do at this very moment that I decided to initiate the course. So first of all, you have to be able to go to the SJECCD instructor.com, and then you should be there. Another way of going to the course is if you go to our college webpage. If you go to our college webpage, in the right hand side of our college webpage, there is a link to Canvas. So click on it. And it gives instruction on how to access the site, and then you should be there. Once you put your username and password, find the course, and let me show this course as a student. So okay, so this is the course as a student view. If you look in the right hand side, um, there are all the to-do lists. This is fundamental right here, to do. By the way, let me allow you to see what I'm showing. There you go. So on the right hand side, you have your to-do list. So always look for this to-do list. Those are the things you have to do. So complete overall final grade, I'm going to take this out. This is not for us, it's some lost material, but basically this needs to be done. Take extra credit, chapter 1 homework and chapter 2 and 4 homework, because they're going to be due on January 7. So pretty much this to-do list gives you assessments that are going to be closed this week, and those are things you must do. Since you completed orientation, then you know that homework are required and extra credits are not required. But I recommend you to do anyways. Um, Coming up is things that are going to be closed also uh, uh, later on. So chapter 1 homework you have to do, and you have to do that one. So those are the three things that are coming up to be closed. So always look at your to-do list, right? And always the coming up assessments, you should be able to pay attention to the due dates. So due dates on January 7, there are a bunch of extra credit, and yes, I recommend you to do. There is a discussion that is going to be done on January 7. You have to do it. And homeworks 1 and 2, they're closed on January 7. So out of the required work, discussion 1, homework number 1 and number 2 and 4, and extra credits if you have time. Now, you can also pace yourself by the modules. So if you pace yourself by the modules, chapter 1, in January 3 or 4, you should be focusing on this material. So I have a discussion to do. And if you click on discussion as a student, you have to go through the video. And then you have to write a non-technical opinion about how big the universe is. So by non-technical is just let's warm up our engines, right? Our motor for our trip. So it's the first discussion. Is very simple. You don't need to put a lot of emphasis on technical terms, as we are going to in following discussions. And I have a question you have to answer, and that is place all those objects in the order of size from the smallest to the biggest one. And pretty much that's it. So once you type your reply, so technically, you should be able to see other replies of other people. So all these people have already put a reply, and then you can check it. As you can see, people are working. That's very nice. And by tomorrow morning, I will start posting answers to the discussion and grading them, so you know which grade you got in your discussion sections. And homeworks are multiple choice. Let me show you that. Chapter 1 homework. You open up and you have 10 questions to answer, right? And then you can try it again and again and again if the grades are not the one you want, and the software will pick the highest score of all the attempts as long as you submit them before the due date. In this case, it's going to be in January 7. Okay. Now let's take a look at the book. So the book we are using is OpenStax. And so you go to OpenStax, and then you click on Subject, Science, or you have the link already established in your course, find astronomy, and there you go. You can download the entire book. Now it's download here for me. And now you have the book in there. And then you can read the chapters in any order you want. So you go, well, chapter 3, you are chapter 3. Or you can go to chapter 1. There you go. And then you have, the content in there. The nature of astronomy, the nature of science, laws of nature, numbers in astronomy. And you have few examples. And pretty much that's it. Now, the advantage of downloading a PDF is that you have a little bit more of a content than reading the book directly right here. So you go to the subject, science, and then you find your book. So besides downloading a PDF, you can view the book online. So you click view the book online. It's more friendly use user, right? You have the introduction, you can search for contents, and then you have the sections, and then you can read there. It's better to navigate. I think is a little bit better, right? But if you have problems at the end of chapter and you want to find them in some other publications of OpenStax, these problems don't appear if you choose view the book in the web. So you have to download the entire PDF, and then you can see the questions and the problems in there. Okay. So today, and basically, in fact, today, basically. So if you go to our modules, today we are, and tomorrow, in fact, 3 and 4, we are, in fact, yesterday and today, we are focusing chapter 1. And tomorrow, we're going to be focusing 2 chapters, January 5th and 6th, which is tomorrow and Thursday. So it's a big material. It's a big material. So it implies, the sky motion and the Earth and Moon system, eclipses and moon phases and lots of stuff. So basically, I start in the modules. I have the pictures organized in PowerPoints. It might be a nice tour through the chapter, and that's what I recommend you guys to do if you are studying the book and following the steps and trying to be as efficient as possible. Instead of just going ahead and open the book, I recommend that you browse through the figures so you know what is in there, right? So there are 17 slides that will not take a lot of time. And then you go, okay, what's chapter 1? Is the science in the universe. And then you have something funny here. So what is this? And then you learn there is something called galaxies. And then galaxies, you have 2 galaxies interacting here. And galaxies in the textbook, now we have to go to the textbook, it shows and identify them as being complex systems with hundreds of billions of stars and gas. And then we call that a galaxy. So then we kind of start suspecting that stars are not just, populating the entire space in the universe, but they are organizing in galaxies, basically. So what else we have there? Oh, there is something funny here. What is this? Oh, this is Mars. And then you have a picture of Mars. Mars is a planet and it has features, landscapes, and then we are going to learn what they are. Stars also in this figure show a stellar corpse, which indicates that probably one of the subjects we are going to focus is not just stars, what they are, but stars, they are formed out of something, they evolve, and eventually they turn into something else. I mean, stars are not living organisms, so they don't reproduce themselves, but we use the term birth of stars and the death of stars, which are words usually associated with living organisms, and we use the same words to describe stars and stellar evolution because stars are formed out of gas and dust. So gravity, the force of gravity, pulled this gas to a point where stars eventually formed, and they are all sort of physical processes that transform the gas inside the stars, and the stars then undergo changes, chemical changes, and eventually the energy source these stars have eventually exhaust, and they start just die. I mean, there is not a cremation and things like that, rituals, but the stars, they are born and and they evolve. But the stars are born out of what? Gas and dust. And then we learn that the universe has nebula, or nebulae. So nebulae are group of gas, and this gas represents the main ingredients of star formation. So stars are formed out of gas, and this gas must be found somewhere. And Orion is one of these nebulae that includes several sites of star formation, and and this is what the gas itself represents, is a point of star formation. And then, well, how do we know everything we know about astronomy? Well, because we have instruments that allow us to see things as if they were closer. In fact, what these instruments do, magnify and capture light in very specific ways that allows astronomers, and astronomers are physicists. That's why nowadays you can call professionals not necessarily as astronomers, but astrophysicists, because we learn about celestial objects using the laws of physics. And so what telescopes do, besides just bringing and allowing us to do awesome pictures, what telescopes do is to bring light and place light in such a way that physicists or astrophysicists can interpret the light. And by interpreting, they can tell how fast, how big, how hot, how dynamics, how magnetic all these materials are, and then with that we can create a picture of the universe that we live in. And here's our home, planet Earth. This is Earth, Moon in scale. See that? This is Earth, this is Moon. It's one of the tenets of chapter 1 is to give students an awareness of how empty this space is. And we start that with our solar system. So if you take 30 Earth, put one next to the other, then eventually on the 31st, we are pretty much close to where the moon should be. So which means you take 30 of these little balls and then you put one next to the other, that's where the moon should be, a quarter size of Earth. Okay. And so pretty much chapter 1 is a tour to what is out there, right? And eventually we observe all of that and we make sense of all of that. And astronomy is not just a theory of things without demonstration and verification. Astronomy is part of the science. And what exactly science is? Well, science is kind of a process that allows us to create windows, enabling us to understand how nature operates. So by science nowadays, and specifically after Galileo Galilei in 1600, we understand science as a body of knowledge that has been verified by exhausted experience and experimentation. So every sort of statement we make has to have the ability of being negated. So contrary to what people think, I mean, people in general think that science deals with the truth. We don't. We don't deal with the truth. What we do, we explain how things are, using the laws of nature that have been verified, and using the laws and use pretty much mathematical language that is the tool astronomers use in order to prove their theorems, their hypotheses, and to create a body of knowledge that we call scientific knowledge. So we do not bring pieces of galaxies and pieces of stars and pieces of anything into a laboratory like in biology or in chemistry or even in physics we do. In physics we have laboratory that is mesh particles and create other particles, and then we can apply the laws of conservation of energy, momentum, and mass conservation in order to interpret the results. In astronomy, we don't bring those materials down to a laboratory, but we observe them. And telescopes allows us to take the light, spread light into rainbows, and then physicists can use the tools of what we call spectroscopy and photometry in order to interpret what the universe is. And the interpretation is self-consistent. I mean, don't think that we make speculations without having backup and supporting ideas and verification to what we claim. It's not just a vain theory that cannot be verified. I mean, when we say that the sun has a surface temperature of about 6,000 Kelvin, this information is verified by the way light behave. Not only the sun, but the light we capture here that comes out of the sun, and the way light interacts with matter in the laboratory. So there is a lot of verification on all the theories we made about not only how the universe is started, because we know how light and matter interact. So stars are not formed isolated, they formed in clusters, and this is going to be one of the main subjects of our course. So we initiate this journey with one step, and the very first step is that is the universe. The universe is a expanding system, an expanding space that, for all we know, started at about 13.7 billion years ago in a very dense and hot and concentrated state of matter and energy. And this expansion still goes on. When we observe galaxies that are very far away, we find no matter which direction we look, all these galaxies seem to be moving away from us. Not because they are moving away from us, but because the space that happens to exist between us and these galaxies, no matter which direction we look, the space is inflating, is expanding. And then we observe that, we can measure that. This is not just a theory, it's based on verification and measurements. So pretty much this is chapter 1, and you should finalize chapter 1 having an understanding of how large and how empty at the same time this space is, and then you should be able to play up with homework and discussions. Okay. The file for extra credit is locked. Okay, I have questions here, so let me see. Professor, the file for extra credits is locked. And I had a question about the first discussion about the list. What do you mean by water? Well, water, in fact, water is a funny thing. We depend on water, and as far as we know, living organism depends on water to process chemical interaction with the environment. And later on, we are going to learn there is a very strong and powerful trend from scientists to look for the existence of biological beings and life activity in other planets, in other systems besides Earth. But we work with an assumption, and for that to happen, we need water. So Earth doesn't have a lot of water. Most of the water existent lies in the oceans and ice sheets. And water, if a liquid or ice or solid, is a complex molecule. In fact, not so much complex, but is a molecule of 2 atoms of hydrogen and 1 atom of oxygen, basically. You're saying that Earth is 80% of water, but it's not true. Where did you see that? I mean, the Earth's surface is covered 71% with water, covered. So if you take all the mountains and valleys and smooth it out and make Earth a perfect sphere, water would be a skin of 2,000 meters, 2 kilometers basically. 2 kilometers, which is 1.6. Yeah, 0.2 kilometers. So 1.6, about 1.2 miles, 1.2 miles in depth of water. So it's not a lot if you think that Earth has a whole radius of about 6,500 kilometers. So what is 2 kilometers? Nothing. It's just a very near thing. So the Earth crust is primarily silicon and oxygen. And if you go deeper below Earth crust, you have more iron, you have more nickel, but you have Earth pretty much being a solid body, not so much water. So 80% is too much. I don't know where you saw that. So let me check about the extra credit. Which file for extra credit is locked? You have to be more specific here. Which one are you talking about? Akash, which file are you talking about? Well, I think Akash is not there. Are you there? Is anybody there? Akash, are you there? Alexandra, are you there? Nope. Oh, yes. Oh, okay. Oh, no, I unmute your phone so I know you're there. You don't have any question, do you? And I unmute Akash now. Okay. All right. Okay. So, Akash, you have to let me know which file is locked. I have no idea. When you ask any question regarding any of the assessments, please copy and paste the assessment so I know which one you're talking about, or try to be as specific as you can. All right. Any question you guys want to ask? Alexandra?
No question.
No question? Okay, now I heard you. Okay, very good. And I'm muting you now. And Akash, have any question? Akash, yeah, I can't hear him. All right. Okay. So I will now upload this discussion, and tomorrow I will go over and explain the Earth Moon system and the three types of night sky we are subject to. In fact, um, I could go and show you that as a preview for tomorrow. Just a second. Um, There you go. So if you go to a place that is completely dark, you might be able to see um, more stars than you would otherwise see in our polluted city with a bunch of lights and everything. Um, and and the ancient astronomers, they saw that, and not only that, they realized what they saw in the sky keep changing position, not only on an hourly basis but also over the period of several weeks. To explain this motion, it was easier to assume or to think of all these stars as being part of what they call celestial sphere. So celestial sphere really doesn't exist. It's not a bubble that surrounds us and happen to be at certain distance from us. As we saw in chapter 1, our solar system is part of what we call a galaxy, Milky Way galaxy. But for purposes of navigation, for purposes of um, understanding motion and the apparent motion of planets and stars in the sky, the notion of celestial sphere is still exists. And we use navigation um, not only um, not only for the purposes of identifying position of stars and planets, but in the sun, but also to identify positions of galaxies, positions of quasars. We use and we think, we kind of imagine they happen to be in this hypothetical celestial sphere. But again, it doesn't exist, but it makes life easier. So tomorrow, I would recommend that you read and you go through these slides. And tomorrow, I will show you not only a software that displays a nice night sky, and I will emphasize the three main types of motions that we experience on a daily basis. The first one is the so-called daily or diurnal motion, which is caused by Earth rotation on its axis of rotation. So the daily or diurnal motion gives rise to days and night. It explains why we see stars in a given position in the sky, and then 1 or 2 hours later, they are not in that same spot anymore. They kind of drift westward. And we are going to identify that as the daily or diurnal motion. A second one is indicated in this picture here. So Earth, as you can see in this picture, goes around the sun. The sun is in the center of the solar system and Earth just go around. And as it does, we see the sun. Imagine you are on Earth. Imagine that the sun is not as bright as it is, and you could look at the sun and at the same time see the stars in the far back. So we would see, by the way, never look straight at the sun. It's always good to remind you about that. So as Earth goes around the sun, we see the sun going and migrating through a group of stars we call the zodiac, right? So this is the second motion. It's called Earth revolution around the sun. And the third type of motion is due to the fact that the moon and the sun pull Earth gravitationally speaking, these two bodies, Earth, Moon, and Sun, pull Earth in such a way that make its equatorial region bulging, and that creates what we call precession. And precession is the third major motion that we are subject to, and precession takes about 26,000 years for a cycle to occur. So think about the first motion I mentioned, day and night, it's just 24 hours in average. So one day. Now, the second one, Earth revolution around the sun, it takes a year. So we are talking about 365 days and a quarter. Now, the third major one is very difficult to perceive. And in fact, it took generations of records in order to be able to allow philosophers to say, hey, there is a third thing going on. Precession is 26,000 years, is a lot, huh? And those are basically the three major types of motion. If you understand them, you can then use arguments to question claims such as the astrology claims, right? That the stars or the planets have any affair or any interference on what you do. I mean, there is no connection between planets' positions and stars' positions and people's behavior. It might, if you have the moon in a certain position or the sun, it might make people moody. That's understandable, but there is not such a thing as planets influencing people's characters or actions. In fact, 2000 BC, that was the claim, that was the thought, and this thought led in Mesopotamia, in India, in China, and Japan to create astrological systems. And some of them are still pretty much used, some of them almost as a religion, and people just do it, but there is no physical connection and support of that. It's more like a religion, if you will. So if you believe, you believe. That's fine, but there is not a real connection between planets' position in the sky or in the zodiac and people's behavior. So we're gonna go over this type of material tomorrow, and also the second part. So it's gonna be a slightly bigger class tomorrow, and that has to do with the Earth and Moon in the sky and the Moon's phase, and why do we have Moon's phases, and why do we have seasons? So seasons are not caused by the proximity of Earth in respect to the Sun. Like in the summertime, Earth is closer than it is in the winter, but has to do with the orientation of Earth axis of rotation. So once you are done with chapter 1, which is very simple, it's just a tour of what is out there. If you could review the slides for tomorrow, that would be great. Okay? All right, so if no more questions exist, I will close the bar. Let's see if I have any of you have questions. I don't think so. Oh, the files are now unlocked. I was talking about the extra credit for that. Oh, so it's unlocked. Yeah, I don't know what. Sometimes I don't know when you try to unlock this extra credit, but everything is supposed to be open beginning yesterday. That's what I heard. But again, since I'm using this book for the first time, and I'm still creating new assessments, it might have some problems in there. If you find anything, just please let me know. Okie doke. All right. All of you have a nice day. Thanks for coming.